exciting. I'm going to start in just a second, but before I do that, I will mention these are all open source slides, as is all of what else we're going to talk about. There's a URL to download them. Please feel free to snap a picture of that or punch that in. You can get a sneak preview. Oh no, apparently it's the wrong link. That's super embarrassing. Well, that's links to some slides. In all honesty, it's links to basically the same deck, probably the same deck that I gave a week ago. So it's going to have the wrong title. It's still the right slides, and I will just look stupid. I'm fine with that. Okay, it's 11:05. I think we should start because this is a pretty packed agenda. I guess I've got 45 minutes to get through what takes way longer than that, so I will do my best. Such is life. So a little bit about me. I feel like I know lots of faces in the room, but also lots of faces I don't know. That's a lot of fun. Cool, it's fun to be at DevDays, our first US DevDays. I've been doing basically this tutorial at the Amsterdam DevDays since the very start of it. We started off, I've given this in many iterations, but the basic content has kind of stayed the same. This session is a real basic introduction to HAPI FHIR. There are 3 sessions over the course of DevDays that cover various HAPI topics, and I'll tell you about those in a minute. But if you feel like this is only getting started, don't worry. There's a whole bunch more you potentially could go through if you really want to learn everything about HAPI FHIR. A little bit about me first off. I've been leading the HAPI FHIR project. I really need to update that slide. I think HAPI, I've now been at it, 16 years, which is crazy to me. I've been leading an open source product for really a long time. HAPI itself, it started a little bit before I sort of came on the scene with it, but I've been at it for a long time because the guy who originally started it went on to do other things. I work a little bit up at a university health center up in Toronto, and these days also work as the CTO for a startup doing integration software called Smile CDR. So that's kind of my background. I've been my entire career, I'm not a medical guy, I'm a computer science guy. And I have been involved in healthcare software basically since the start of my career. I can't imagine doing anything other than healthcare software, so I'm sure a lot of you guys feel the same way. It's fun stuff. The stuff that we're going to cover here within this session, this of course is a basic intro to HAPI FHIR. We're going to talk about how the data model works, how the parser serializers work. Later in the day, we've got sessions on building servers and validation. But really, these first 2 items are going to be our key focus for the start. As I said before, these are open source slides. They're part of a bigger project that if anyone would like to discuss this with me, I'd love to talk about it with you. I've been starting to talk about the concept of open source FHIR training, just because I think this is a really neat concept. Of course, within the FHIR community, since the start, we've been huge on open source software. We've had open source reference implementations and all of that. It seems to me the last remaining thing is an open source community, like a community of training materials, a set of slides that anyone can contribute pull requests to and stuff like that. I have no idea how to operationalize that because of course you can't really put slides on GitHub in the same way that you can code, but I'm still trying to figure out what it would mean to do an open source project of training, but it's something that I'm thinking a lot about lately. So if anyone has any thoughts on how something like that could work, I would absolutely love to talk to you about that because I think that would be a neat thing to do. All of the code samples we're going to show today are all up on the web as well. They're all up on a GitHub repo, and they are all Apache 2 licensed. So all of this stuff is free. Take it and give it. The other thing I always say when I bring this up, and this goes for all of the HAPI FHIR talks, I would be delighted to have any of you take any of these slides and go and give this tutorial yourself. Please don't feel like this is Creative Commons only in name but not in spirit. That's not the case. If you want to give this tutorial next time, I would be really happy about that. So very quickly, how many of you guys have played with HAPI FHIR before? Oh, all of you. What are you all doing here? Hopefully this isn't going to be super boring to you all. The other sessions are a little more advanced, but there we go. I don't think I need to ask the second question. That's awesome. Of course, as prerequisites, I mean, you guys, if you've already used HAPI FHIR, you're well aware that you probably should know a bit of Java. You should probably have an IDE. All of our examples use Maven because I've been doing Java for long enough that I'm still a Maven guy. I know all the cool kids are using Gradle these days, and it all works with Gradle, but I'm too old for that. So there we go. Let's move into it. So, of course, let's start with what is FHIR. I've 2 slides, and I will stop talking about FHIR itself because that's probably just talking down at this point. I always describe FHIR as being, actually, I always say it's 3 things, but these 2 are what the slides say. The first is, of course, FHIR is a lovely data model. It's a model for all things healthcare, going into areas of clinical care and scheduling and research and genomics and you name it, there's probably a FHIR resource definition that covers all that stuff. And frankly, even if you're not building interoperable software, if you're just doing healthcare software that's going to sit on a computer and never talk to anything, I would still say use FHIR just because the data model is so well thought out that you're not going to realize you forgot 18 things in 2 weeks and have to re-engineer everything. So FHIR is just a lovely data model for building things. And of course, FHIR is a RESTful API for exchanging that data. Those are kind of the 2 core things. Really, I should say FHIR is 3 things. It's that plus the massive community that is FHIR that we're all here for. But that's less technical and doesn't fit in with my theme of 2. FHIR, of course, has had 3 releases to date, like 3 major releases, and a 4th is still to come. We had DSTU1 back in 2014, and in 2019, assuming all goes according to plan, we will release the 4th major version, R4. I say that only to mention that within this talk, within HAPI's documentation, within our Maven artifacts, you will see the terms DSTU2, STU2, and R2 mixed use kind of interchangeably. This is an artifact only of the fact that that FHIR itself has kind of changed its own vocabulary a little bit. There is no difference. If I say DSTU2 or R2, I don't mean those to be separate concepts. I'm talking about the exact same thing. So that's why I say that. So HAPI, as I said at the start, we started in 2001 as an HL7 v2 library. Which is crazy to me that this library has been around as long as it has. The original use case was 2 hospitals across the street from each other. One had a Cerner installation, one had a Quadramed installation. They wanted to aggregate the results in a little portal to show our doctor users data from each other's hospitals. So we needed a V2 interface. There was no software for free out there. We wrote a library. And then 18 years passed, and now we're doing FHIR. That's kind of the long version or the short version of a real long story. HAPI has just grown in explosive growth over the years. It's been fascinating to me the way it's grown. I don't have a slide about this, but I think it's interesting. Weirdly, the V2 library has been around for since the start, since 2001. 2 years ago was the first time ever usage of HAPI, or at least our Google Analytics tracker on the HAPI V2 website. It's the first time it went down. So we finally have hit a tipping point, I actually think, where interest in V2 is going down as opposed to growing, which it has for the last 18 years. So I think that's really interesting. And of course, the reason that's happening is because all of a sudden interest in FHIR is skyrocketing. So we hit a crazy tipping point 2 years ago, at least in Google Analytics tracking for the 2 HAPI projects, which are sister projects but are not the same project. HAPI FHIR itself, I always like to, people when they start sort of looking at HAPI often get confused by the fact that there are seemingly 2 implementations out there, and I need to give a bit of history just to explain that. HAPI in the early days of FHIR, so pre-2014, there were 2 libraries in Java for dealing with FHIR. One was HAPI FHIR, one was the so-called reference implementation, which is basically all of the Java classes that build the FHIR spec itself, like the website that you see when you go to hl7.org/FHIR. Those started as separate libraries because they had very different purposes. One was around building FHIR, the specification. One was actually very specifically built to support a set of web services we were building in a hospital up in Toronto. Over time, we realized these were 2 sort of duplicate projects doing the same thing. So actually at a meeting at the DevDays event in 2014, we decided let's merge those 2. Spent some time doing that, and at this point, those are sort of merged libraries. So there still is a bunch of code built in the FHIR spec build, or however we want to call that. There are no longer two libraries. If you want to do FHIR in Java, HAPI FHIR is the exact same code base you would find anywhere else doing Java, so those are no longer separate. We have a bunch of design goals in terms of standing up the library, and they really come from sort of the spirit and the ecosystem of Java and its many, many open source libraries that are out there. These days, I mean, anyone doing sort of frameworks in Java will follow very similar sort of principles. We're, of course, all about open source. We're Apache 2 licensed. We're very, very encouraging of commercial software. So, people taking this software and putting it into products they're going to sell, we 100% encourage that. Certainly, that comes with no obligations to tell us about what you're doing or, give us, you don't really have to give us credit or anything like that. Certainly, we're very encouraging of commercial products using the HAPI FHIR library. And we know that overall, this sort of strengthens the ecosystem of FHIR out there. We were really heavily influenced by frameworks like Spring. And if you guys are Java developers, you probably either love or hate Spring. There are people that fall on both sides of that camp. The thing that I personally love about Spring is the fact that you can take one little corner of that framework, despite the fact that it's massive, and use that little corner of it without needing to use anything else in Spring. We've tried to take that same ethos with HAPI FHIR. So certainly you could use the data model by itself, you could use the parser by itself, you could use the client by itself. You're not sort of bound to use every last bit of HAPI within your library. I always have to give the .NET implementation, Firely's .NET API, some credit there too, because we talk constantly, and they've stolen lots of ideas from us. We've stolen lots of ideas from them. I don't know who's gotten more good ideas out of who. Probably more has come to HAPI than from the .NET than the other way around, because AWOT's really good at API design. We exchange ideas a lot, so there we go. Come on, there we go. Where does HAPI come from? People are always sort of curious what supports this. There's sort of four big sources for HAPI FHIR that are sort of paying the bills for HAPI. As I said at the start, I'm with a startup, Smile CDR, that is employing a couple of developers these days to work on HAPI FHIR, but it's not our only source. FHIR.org has supported us quite well, actually, in terms of providing server space and stuff like that. University Health Network, where the project started, still does employ people who work on HAPI FHIR. And interestingly, we have gotten quite a bit of sort of operational funding over the last few years from the Juvenile Diabetes Research Fund, who very generously have been interested in sort of moving forward the ecosystem of data exchange for, very specifically for enhancing diabetes care. And they have funded efforts, among other things, to enhance Bluetooth standards, to enhance diabetes, like glucose meter device exchange standards. And more recently, they've been really interested in EHR standards. So naturally, where do they turn? FHIR. So they've been really interested in that. So enough about the landscape. Let's talk about the library. HAPI is a great big beast of a project. I suspect a bunch of you have looked at our GitHub page previously and been overwhelmed. You're not alone. At this point, it overwhelms me as well. It's a lovely problem to have, but we've reached a point where, we've had so many contributions from companies who have devoted lots and lots of time to writing wholesale modules of HAPI that I don't think there is anyone, myself included, who knows the entire library. There are modules in there that I certainly don't know how they work. The JAX-RS support, for example, that I'm not going to talk about today, was contributed and continues to be maintained by AGFA, who use that in one of their core products. And that's one example of a really big, sort of very generous contribution. And I say this only to say that HAPI is absolutely a gigantic library with lots and lots of corners. We're certainly not going to cover all of them today. And one of the things I would really welcome is feedback in terms of what parts of it we're not covering that we should, or what we are covering that maybe is too basic for you guys, because I'm based on the hands at the start. I'm feeling we're going to see some of that. So this is the schedule for DevDays in terms of what we're going to cover. Today we're going to talk about classes, parser serializers, and the client in this session. This afternoon at 3, we're doing a joint .NET and Java session talking about validation, and that one sort of spans over 2 sessions, because it starts a little bit sort of as a talk and then turns into a discussion, just because validation is one of those topics that can go in every direction and is fundamental to using FHIR. And then tomorrow we have an advanced session covering servers, where we're going to talk about standing up a server and all of the components that go into that. So this is kind of the overview of the things we're going to talk about over the course of DevDays. So let's dive into the library. One of the things that people find a bit confusing when they first start into HAPI, and maybe you guys have tripped over this, there are 2 version numbers at play, and hopefully this isn't just too basic and you're all bored by this, but HAPI, of course, is a library, and we release new versions and we give those we give those versions numbers, just like every software that ever existed does. FHIR itself, of course, has versions as well, and those 2 things are independent of each other. So every version of HAPI supports a couple of versions of FHIR. This table gives you a little sense of that. The 1.0 version of HAPI supported DSTU1 and had some early drafts of DSTU2, because at the time DSTU2 had not been finalized, like it hadn't finished the ballot process. By the time HAPI FHIR 2 came around, we supported 1 and 2, and we supported some early drafts of 3. HAPI FHIR 3 was released at the same time as the R3 version of FHIR came around. So at that point, we dropped support for DSTU1 because it seemed like no one was using it anymore, and nobody really complained, so that seemed like it went okay. And I suspect, in early 2019, we will be releasing probably HAPI FHIR 4. That will support a finalized version of R4. I doubt we're going to get to drop DSTU2 support anytime soon, because of course all production use of FHIR, or at least almost all production use of FHIR here in the US, is on DSTU2, and probably will be for a few years. So if you're worried we're going to drop DSTU2 support, I would love to say we're going to, but I don't think we can. So it'll be around for a good while, until nobody is using it, at which point it'll go away too. We distribute as a part of HAPI a bunch of what we call structure jars, and each one of those jars is a specific version of the FHIR resources. Within those jars are a bunch of classes to represent the various bits of data model. I'll talk more in a second about those, but I will mention they're all in separate packages, so you can certainly into your project bring all of these jars if you want. It is perfectly feasible to write a HAPI FHIR application that supports DSTU2, 3, and 4. I'm not going to say it's trivial. You do have to deal with the fact that they're different classes, and there are differences in the data model that you have to work around. But it is absolutely feasible to do, and I know of lots of people who have production applications out there that are in parallel supporting 2 versions of FHIR, one way or the other, and there are a few strategies to do that. We have a complete set of these structure classes, as I mentioned, these resource classes. There is one for every one of the resource models within the FHIR spec. So FHIR defines a resource called patient. We've got a class called patient. FHIR defines a resource called encounter. There's an encounter class, so on and so forth. All of these classes extend from one base interface called iBase resource, and then there are package names that, I've got a mouse here. So org.hl7.dstu3, that's the DSTU3 version of it, and then the DSTU2 package has an equivalent class called patient. These classes look very similar. They're all going to have methods like getName and getGender and that type of thing, because those are the properties. They are in different packages though, so if you're trying to support 2 versions of FHIR, you are going to have to write a little bit of duplicate code to populate one version of the patient and the other, which is hopefully something we will improve over time, but for now remains a factor to think about as you're dealing with multiple versions of FHIR. There are data types as well, defined within the FHIR specification, and as I'm sure you all know, we have a set of primitive data types in FHIR, so strings and decimals and booleans and all of that type of thing. All of those are represented as wrapper classes within HAPI FHIR. So there is a string type and a decimal type and a Boolean type that deal with those. We just basically take the name of the FHIR primitive and add the word type to the end of that. We've also got a set of composite data types. So FHIR defines things like quantity or ratio or human name or address. All of those are composite data types in FHIR, and we've defined Java classes that represent those things. And those, I mean, we've got some examples up on the screen. One question we often get is why do things like string type and decimal type even exist in the HAPI library? Because of course, Java, the language, has of course strings and decimal numbers and Booleans. People often ask about what is the deal with that. The reason for that, if you're curious, is that of course, this is a FHIR rule, you can put extensions on almost everything in FHIR, and that includes primitive types. So within FHIR, it is perfectly feasible for you to have a primitive string and then have an extension on that. A common example of that would be like a localized version of that string. You might use an extension to store a translation of that string or something like that. So string type in that case would hold the string that you had, and it would also hold the extension. I'll show an example of that later, but that's the reason why we have these wrapper classes that deal with that. There are Java docs up for all of these data model classes. I'm not going to click on these links, but of course the Java docs are up on the website, and if you're using a modern IDE, you can also import that straight into your IDE, which is nice. You get all the nice autocomplete and all of that. The Java docs for the structures do include all of FHIR's definitions. So, if you go and look at the method getGender, for example, you're going to see FHIR's definition of what that field is and any sort of rules around how it's used and all of that stuff. So certainly take advantage of the Java docs. If you haven't loaded them into your IDE, you should. Let's go through how code works. And I realize, I think that screen is small enough. This is probably hard to read from the back. Hopefully you guys can roughly see that. The general deal with using, with creating any of these with creating a resource basically is, you would call the constructor as you would. I'm going to create a patient object, and then I'm going to set properties on it. So name is a repeatable field. I'll say .add name. One thing I will point out here, we are big believers in sort of fluent interfaces. Almost everything when you're interacting with the model sort of returns a reference that you can use to chain things together. It's always hard to explain in any other way than showing examples, and this is a nice one. If you're populating a name, I can say name.setFamily.addGiven.addGiven, and I can sort of indefinitely chain these things together. The idea being that, if I had more screen real estate, I would sort of nicely line these things up and all of that. Take advantage of that. The nature of populating sort of a data model like FHIR lends itself really well to these fluent interfaces where you can sort of chain things in a logical way and make fairly readable code for populating data, which is nice. As I mentioned, always take advantage of autocomplete. Load Java docs in and stuff. I feel like I should have an example of the Java docs on this slide, and I don't. But the point is, if I say add name and hit command space or control space, I'm going to get a little definition of what the name field is. So use your IDE to its power. It's good. There are a whole bunch of enum values. Java, of course, has enumerated types. FHIR has enumerated types, and those things are good fits for each other. So for things like contact point or patient gender or address type or any of the many places in the FHIR spec where we've got a set of allowable codes, there are enums that you can use to fill those out. This is not a session where we're going to go into all of the nitty-gory details of binding strengths and stuff like that. I will mention that not every codable value in FHIR has an enumerated type, because of course in FHIR enumerated types are closed. You can't add more enums. You can't extend an enum in Java. So anywhere in the spec where we have an open binding, meaning you can add your own codes there if none of the provided codes meet your needs. We do not provide enums for that. So sometimes we get questions about why is there not an enum for observation code, for example. And the reason for that is because you could not create an enum that has all of the possible codes for observation code. I was talking a minute ago about the primitive types and why do they exist, and of course it's so we can add extensions. I say that just to mention that you don't have to use the wrapper types. Actually, that's not even what this is getting at. I guess what this is getting at here is that those wrapper types are in fact just wrappers for native Java things. So Boolean type, of course, inside just has a field which is a Boolean. Decimal type, inside it has a field which uses the Java big decimal class, and so on and so forth. You can always interact using the sort of primitive Java things. So you can always say set value and just use a Boolean a Java Boolean. You can also always interact with the FHIR representation, which is sort of a string version of that. There are places where the distinction there matters. In the case of a Boolean, it's kind of a trivial distinction, but for things like decimal, Java's big decimal doesn't have a concept of precision at the end. It doesn't remember the zeros at the end of a number, for example. But the decimal type does, so you can always sort of interact with a string version of the number. You can call set value as string and say 1.2 with as much precision or as little precision as you want. That is an allowable thing, and as of last week, engineering values just got added to the FHIR spec as well. So the latest version now allows you to do 1E, O2, whatever, the engineering format, and that's just been added in there also. Yeah. So that is the data model. Let's talk a little bit about parsers and serializers. So FHIR includes a couple of parser serializers. We've got support for the XML format and the JSON format. FHIR itself does define a third format. That's the Turtle RDF format. HAPI does not yet support Turtle. It's one of those things where I keep hoping one of these days we will have enough time to implement that, and we have yet to ever find the time to do it. If anyone here is super into Turtle and wants to take a crack at that, certainly we would love some outside help on that. But to date, we don't have support for that format. The entry point for using HAPI FHIR, and this goes across the board, whether you're using the client, the server, the model, the parsers, whatever it is you're doing, is a class called FHIR context. Everything that lives within HAPI sort of stems around this FHIR context object. I'll say this now, and I'll probably repeat it because it's a big gotcha in using HAPI FHIR. The context object is designed to be completely reusable, but it's a big, heavy object. So the biggest anti-pattern in HAPI FHIR, and I've seen lots of people fall over with this, is creating context objects over and over again. If you're building a client application, for example, the worst thing you could do is create a new context object for every client request that goes over the wire, because context takes a while to boot up. On the other hand, context is 100% thread safe, so there is no problem whatsoever with sticking it in a static variable and forgetting about it. I'm confident in saying it doesn't have any memory leaks, it doesn't have any serialization issues, it doesn't have any thread safety concerns. You can do whatever you want with FHIR context and be confident things are going to work. Just don't constantly create new ones because you'll have performance issues there. This is even harder to read on this screen, but there we go. I wonder, can I zoom that?
Can I ask you a question?
Yes, absolutely.
You said the context not to initialize specifically. Are you looking at it from a microservice kind of architecture picture? Do you have any calculation?
Well, I mean, I think those are, so the question was, are we looking at this from a microservice architecture sort of viewpoint? I think there are orthogonal problems. The reason that the context takes a while to boot up, I mean, what it's doing when you initialize the context object, actually what it's doing is going through and scanning the data model, because our data model has a bunch of annotations on it that sort of give the parsers and the serializers hints as to what the fields are. And that sort of meta model that's loading into memory takes a little while because we're doing reflection and going through. I mean, ultimately, I don't know that there's much we could do to slim that down. In theory, we could have it not scan the entire data model until bits of it are needed. Actually, that's not in theory. There are settings that cause it to do exactly that. Yeah, you know what? I changed my answer. There are settings here that were added basically on behalf of the Android version of the library. And Android sets these settings by default. You could also set them as well. They're on the context object. They configure how much of the model gets scanned as it boots up. So there are ways of slimming down what it does, yes. So containerization, I think that applies more to the server side of things. And yeah, I'll definitely, within the server talk, we'll talk about containerization for sure. Yeah, so bottom line, once you've created one of these context objects, and for anyone at the back who can't read that, what I'm saying is I'm creating a variable of type FHIR context. I say FHIR context dot, and there's this thing for DSTU3. There's a bunch of factory methods on the FHIR context object, one for each version of FHIR. So in this case, this is a context to handle DSTU3 parsing and serialization. So I say dot for DSTU3. And then from the context, I can ask for all kinds of things. In my example here, I'm saying dot new JSON parser, and that's giving me a new JSON parser. There are methods on there, new validator, new client. There's, basically the entry point into anything HAPI FHIR is create a context object and then ask it for whatever, whatever thing you want. I should mention that this JSON parser, within HAPI FHIR, the parsers handle both parsing and serialization. If you're looking to do encoding, there's no method .get JSON encoder. You ask for the parser, and the parser handles both sides of that equation. That's another sort of thing that people sometimes get confused about. The parser has all kinds of configuration options on it, and I won't go through them all. You can find them all pretty easily. But the one that all of my examples will do is say parser.setPrettyPrint to true, which means, of course, make it all nicely indented and takes a bit more space over the wire, but it's easier to read. And then the parser's got a bunch of methods for actually doing encoding. So my example here says .encode resource to string, and the output of that, of course, is going to be a nice big encoded version of my test Homer Simpson patient. That will come out there. Parsing works roughly the same way. So again, I'm going to say parser.parseResource. I'm going to pass in a string, and then ultimately I can use all of the getters that exist within the data model to pull stuff out. So parsing and serialization, I mean, there's not much more to say about it. It certainly is not rocket science. And if you've ever used a library like JAX-B or any of the many parser serializer frameworks in Java, HAPI will work very similar to any of those. I certainly don't think anyone will find that terribly confusing. Let's talk quickly about clients. How am I for time? I'm good. So, of course, in FHIR, there is an extensive REST sort of specification. These are the basics. There's a whole bunch of, your basic CRUD operations, your search operations, that type of thing. All of that is represented within the HAPI FHIR library. I'm not going to go through everything in the REST specification because that would be a 10-hour thing. But I will say that there are all kinds of advanced and really neat features within the FHIR spec itself. Conditional creates and version-aware updating and nested chain searches, all kinds of wacky things like that. Basically, all of that is supported within the client framework. What I'm going to show you here is a bunch of examples of how to do some of this stuff within HAPI FHIR, and then I'll point you to where you could learn about the rest. And certainly, I will say that I'm around if anyone's wondering, how do I do wacky thing X? I'm happy to talk about that. There are two flavors of the client within HAPI because, everything in HAPI seems to have at least two ways of doing it just because of the way we've grown. There is an annotation client, which is not our focus for today. The annotation client sort of models JAX-RS. So if you've ever used a library like JAX-RS, which sort of works on this idea that you form interfaces with a bunch of special annotations that sort of spell out exactly what methods do I want to supply. That was the first client we wrote. After that, we realized it might be nice to have something that's a little bit less heavyweight. So we came up with this sort of fluent client that allows you to do things a little bit less sort of static. That ended up being the really popular one. So today I'm going to talk about the fluent client only. Not to say that the annotation client is not still supported. It's still actively in use. It's still actively in development, but it's less popular. So it's not the one that I tend to focus on. There are documentation. There's documentation for both. These are the links to those two, and there's lots and lots of stuff on that. I am going to click on the Fluent link quickly, just to point out the fact that I'm going to show you a whole bunch of examples in the next couple of slides, but I'm not going to cover everything, and I will point out that there are examples of absolutely everything here. So if you're wondering, how do I do a conditional update, for example, go to the document, click on conditional update, and here is an example you can literally just copy and paste into your application of how to do a conditional update. So whatever thing it is you're trying to do, oh, there we go, that's what I wanted. So whatever thing you're trying to do, if I didn't talk about it here, it is still, it's all available as examples up on the HAPI FHIR website. And of course, that's hapifhir.io, which I should have said at the start probably. Creating a patient, this is getting even harder to read, oh man. The way that this works, of course, is yet again, I'm going to use my context object, my CTX, my FHIR context object. I'm going to say .4dstu3 to create one. I'm going to come up with a base URL, which I know you can't read at the back, but that base URL is the address of your server. In this case, I've got firetest.uhn.ca/baseDSTU3, which is the base URL for The public HAPI server operated up in Toronto by University Health Network. That could just as easily be, thank you, that could just as easily be any other base URL for any other server that's out there. I will say .new RESTful generic client, and that gives me an implementation of this iGeneric client interface. And then on that, I've got a bunch of chained sort of operations. So in my example here, I'm saying client.create. And then from that, I can say .resource, and then from that, I can say .execute. I'm not going to go through all of the options here because there are 1,000 of them, but I will say, if you're doing this in an IDE, it will guide you through the process. On your client, you can look and you will see there's a method called create, there's a method called update, there's a method called operation, there's a method called capability statement. Whatever thing you're trying to do, there's a method to do that. And you will sort of join together a bunch of sort of methods on that chain, and your IDE will autocomplete that, so you'll know what the next thing is you want to do. The one thing you need to make sure is these method chains on the client all end in .execute. My final line down here is .execute, and that is the final thing which actually causes the client to go out and talk to the server and do whatever the thing is that you were trying to get it to do. So in this case, I did a create, I sent it off to the server came back. Updates work much the same way. I won't go through all the details here, but effectively, I'm reading a patient from the server. I'm flipping its gender just to give a simple example of a change. And then I'm calling update, and you will see this exact same example sitting up on the slides if you grab the link at the start. The other thing I will mention if you're going through the slides is all of these examples have sort of weird class names, example 07 _ client read and update. The reason for that is because they're all up on the GitHub that was at the start of the slides. So if you want to sort of go through and run this example, you can find this exact class up on GitHub as well. Search, sure. Right, so I didn't talk about security, and of course I'm running out of time. So actually, hold that thought. I'll really quickly talk about that. I'm a little bit low on time, so I'm going to skip a bit of this. I will say searching is incredibly powerful in FHIR. It is a vastly it can be really simple, it can be really, really complicated. FHIR has provided a mechanism for implementing the entire sort of search specification also, again, in a very sort of fluent way. So if you're trying to do, this is an example for patients searching with a .where and a .and. So I'm searching for patients with a specific name and a specific birth date. I'm limiting to 100 results. So there's all kinds of stuff you can do across the FHIR specification, and all of that is supported. And of course, everything else. So I already said there's support for all kinds of crazy bits of the FHIR spec. I want to talk really, really quickly in my remaining minute about interceptors. HAPI FHIR's client has this notion of interceptors. And interceptors are things that you can sort of use to wrap functionality around your client. Interceptors have a lot of power within the framework. They are able to inspect the content as it goes out and inspect the content as it comes back. They're also able to change the content before it goes out and change the response before it gets looked at by the framework. So you can use that to do really almost anything to your client, including security. So there are a bunch of or not even example, there's a bunch of interceptors that come with HAPI FHIR. For example, the basic auth interceptor and the bearer token auth interceptor. Those are interceptors you would use to add security credentials to your requests as they go out. My favorite interceptor in the entire framework, I use this every time I build anything, is the logging interceptor, which is this sort of configurable thing that you can use to, it can log just the URLs that are being hit. It can log the entire payload. It can log the headers if you want. So it's sort of very flexible in terms of what it logs. I love the logging interceptor. There's also the capture interceptor, which allows you to actually grab the payload and do processing on it yourself. Those are a couple of examples of interceptors. Really, there's all kinds of other things you can do with interceptors. I've seen sort of endless capabilities there. This is a simple example. Basically, on the client object, which I had requested, I can say .register interceptor, and I can pass in anything. Here I'm passing in this thing called cookie interceptor, which adds cookies to the requests that are going out to the server. You can also create your own. Is that the next example? No, it's not. You can also create your own. There's an interface in HAPI called iClient Interceptor, and it is definitely designed to be implemented yourself. It only has a couple of methods, so certainly whatever behavior you need on the client, whether it's logging things, whether it's modifying requests, maybe it's cleaning up data, you can use it to, to filter out bits of the data before they go out or before they come in. Like whatever the use case is you have, the Interceptor framework will probably allow that. So definitely, I mean, that's probably the most interesting part of that entire framework. This is the end. I will say this is a link to an example. So if anyone wants to spend some time up at the hackathon part upstairs, try the client out, take it for a spin. There is a link here to what's called the Firestarters repo. I should give a plug to this. I really should update this. It's no longer Furore-Fire, it's Firely Team. But the old one does redirect. This Firestarters repo is sort of this joint repo that's maintained by a couple of projects, including Furore, including the HAPI project, and including a couple of other projects as well. We use it as sort of a central repository for all things getting started with Fire in a couple of different languages. So it's a great place to go and look at examples of code and sort of little tutorials for a couple of different languages. I mention it just because this HAPI Firestarters client skeleton is a nice project to go to if you want to start playing with the client framework. So that's that. Validation will be later. Thank you.